Born ready.
Born ready.
Yeah. Off the phone. Are you taking a snap?
Yeah, 1 minute.
I thought you were finished.
Me too.
Which one are you on?
Uh,
KJ, which one are you on?
Done.
You're finished? Talking?
Let me just take a picture.
Finished? Where?
Finished.
What took you so long?
Did I?
Oh,
Right.
the questions?
Yeah.
What do you think I was asking you when I asked you when you were finished? Of course the questions.
No, I got the answers.
Oh, that's fine. Yeah, you did all the work.
Yeah.
You have all the answers then.
All the
Yes,
answers.
okay, that's fine.
You mean,
Right.
why did you write the questions all the time?
Writing the questions is fine. It depends on your level of English. Alright, in question 1, what do I tell you? Do I tell you N1, N2, V1, V2? What information do I give you?
11 for.
No, what do I tell you? 11 is what?
And 2? 22.
N2 is 22?
Yes.
Okay, what else do I tell you?
V1.
220 is V1.
Yes, and V2 is 11.
And what's N1? Is this the turns on the primary?
Yeah.
Right, fine. So you have V1 over V2 equals N1 over N2. So did you get 440?
Yeah.
Fantastic. Number 2.
V1.
Yeah.
220.
Yeah.
And V2. 1100.
Yeah.
Okay. N1 is 110.
And N2 is what you want. So V1
No, I want the currents.
We want I1.
I want I2, sorry.
We want I1.
Hold on. What is the current in the secondary coil if the main... Okay, well firstly, I should get the N anyways. I need to know the N.
But I think here we don't need that. It's because we already have the 4. Oh, we need the 3.
Yeah. What's I1 is 13 and I2 we don't know.
We don't know.
Okay, so N1 over N2 equals V1 over V2.
So N2 equals 550.
Yep, N2 equals 550. And then
I2 over
I2 over I1
equal 100 over 500.
yeah, equals N1 over N2, I think. Yeah.
100, oh yeah.
Yeah, it's like this. So then I2 equals 2.6 amps. Yeah?
Yeah.
What's wrong, KJ?
I thought V1 was 100.
Is it?
No, it's not.
Okay. Continue?
Yes, please.
Yes? Okay, so number 3, a power plant sends 10,000 volts of electricity to a town and a step-down transformer converts it to 200 volts. The primary coil contains 1,000 windings. What is the current of the high voltage electricity if the low voltage electricity has a current of 13 amps? So we have N1, V1, I1, N2, V2, I2.
N1 10,000.
N1, no, V1 10,000, I2 13, V2 200.
Yes.
What's N1?
1,000.
1,000. And I'm looking for I1, isn't it?
I1.
So you can say V1 over V2 equals N1 over N2. So that means N2 equals 20. Then you can say I2 over I1 equals N1 over N2. So this is interesting because we think about, it's true though, like the power cables, the big power cables you see outside, the really big ones, they're 10,000 volts. So it's a huge voltage, but it's a tiny current. It's only,
And where's the transformer here?
you usually can't see it, but I can think of some I've seen when I was on the bus, but I'll have to find a picture to show you. Actually, yeah, I'll try and find a picture.
They have, like small room or something.
Yeah, now it depends where you're at. So if it's the transformer for a town, it'd be quite big. But if it's a transformer for a small area, it'll fit in a room. I'll try and find a picture here for you. Right, 4. A transformer. Oh, here, I'll get the picture before I do it. Oh, not charging. Step down unit? No. Step down transformer, and I want it for like a small town or something. Can't see it. So these would have 10,000 volts in it. Yeah, we're getting a bit closer. Not quite. It would look something. You'd look something like this. You see these small little stations.
Yeah.
So this is where the 10,000 volts I think come into this, and then here's the transformer here, I believe, for the homes. Maybe I can find a better picture. And sometimes, they're quite small. So I think here's one that's built into the neighborhood power supply. But I do know where it is. It's the last place I remember seeing a small, I think it was there, a small kind of, like it was a few transformers together. Town. Maybe this needs to have a hyphen.
Just one transformer.
No, then I get Optimus Prime
Oh,
if I just have
That one,
transform.
that one, that one, that one, that one. There you go.
Go down?
Yeah, this one.
Yeah, more like this, I guess.
And this
Yeah.
one on the left.
Yeah, I guess.
And my
That's
computer.
Pakistan, that's Pakistan.
Yeah, my computer is the same.
Literally your people.
Are you sure?
Yeah.
If I put in Pakistan here,
Yeah.
Pak,
K.
K, isn't it? Pakistan. Is that right?
Yeah.
Okay.
Oh, there you go.
Ah, no, they're lame little ones. No, no. No, I want a big field of them. Like, kind of like this.
The powerhouse. In fact, the Transformers house for
Transformers house, I'll get Optimus Prime's house. Be like sitting down having some tea or something. Yeah, I'm thinking, now we're talking. I'm picturing things like this. So, you have the 10,000 volts coming in, possibly here, I don't know. and then it's transformed into 220 volts for the homes. So, something like this, anyways. Okay, last one here. You have a transformer with 100 and then 10. Okay. So, N1, V1, I1. N2, V2, I2. So this is 100, this is 10. What's the V1?
220.
And the V2?
Yeah.
Okay. And the I1?
1.
And I want the
I2.
I2. Okay, so N1 over N2 equals V1 over V2. So that means V2 I think will be 22.
Yes.
Yeah? 22 volts. Now, the transformer is only 90% efficient. So that means the I2 is not as big as you would like it to be, because it's not 100% efficient. So what's happened here is power in does not equal power out. In fact, power out is smaller than power in. Because of this. Okay, so what you can say, well, you remember from semester 1 that efficiency, 90%, is power out over power in times 100%. So that means 90% equals power out, which we don't know, over power in, which we could know, because that's going to be I1 V1, because power is IV, times 100%. So that means power out would equal 0.9 I1 V1, which would be 0.9 times 1 times 220, that's 198. But power is IV, so I2 V2 equals 198. So I2 is 198 over V2, which is 22. So that is 9 amps. In fact, it should have been 10 amps if it was 100% efficient, but because it's only 90% efficient, an amp is lost. Where is this lost amp? Well, it's not really, yeah, it's heat. I shouldn't really say an amp is lost. 10% of the energy is wasted as heat. Okay. We close that?